Live. So my independent variable is my people, number of people, okay? We'll call that n. Number of people, we'll just call it n, okay? Because I got to choose the number of people, right? I independently got to choose. And then the dependent variable was time. So the number of people I choose, the time's dependent on how many people. Yeah, so my dependent variable is time. Or t, I totally agree. So here's what my data looked like. I had this chart going, all right, and I had my n here, and I had my time here in seconds. Okay, and I'll give you a second to catch up, and then I'm just going to add my data. So my data was sometimes good, sometimes bad, like all data. We did it, so how good the data is, depending on you guys. It did speed up. I tried to slow you down, right? We wanted to be as consistent as we could. So then I'd have n is 2.3, oh, sorry, my bad. 5 people, 2.3 seconds. 8 people, we had 2.8 seconds. 12 people, we had 5.0 seconds. 18 people, we had 7.5 seconds. 23 people, we had 7.9. You sped up a little bit there, didn't you? 27 people, we had 9.0 seconds. And then 30, we had 11.8. Okay? Now what I want to do is make a scatter plot out of this. And I'll let you catch up on my data. Now if you need graph paper, anybody need graph paper for it? Anybody need graph paper? Graph paper, okay. We're going to try and do a nice scatter plot. So you're going to need graph paper to make it look nice. Anybody else need graph paper? Okay, graph paper. Anybody else? Graph paper. Graph paper is going to make it look nice and neat. Okay. Anybody else? Graph paper. Okay, good. So if I do a scatter plot, I'm going to make sure that I put my axes like this. Now we're going to try and be smart. I know that this is the number of people. And this is time. And I'm going to be smart about this because the number of people goes all the way to 30. So I'm going to change my scales. I'm going to go by 2, 4, 6, 8. Okay, so I'm going to go by 2s on this one. And on my time, I could probably just go by 1. So my scales are a little bit different, but it's still going to work for you, okay? So my scales, I'll go 2, 4, 6, 8, 10, 12, because I need it all fit, right? 14, 16, 18, 20, 22, 24, 26, 28, and finally 30 people. And then on time, I'll just go by 1s. Go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Hopefully you've done a scatter plot before. If you haven't, then you just have to estimate where the points go. Okay? So if you've never done a scatter plot, we're just going to do dot to dot to dot. Okay? Now my dots aren't going to line up, but we're just going to do it like this. Everybody watch where the first dot goes. First dot's 5 and 2.3. So 5 is about there, and 2.3 might be about there. I just estimate. Okay? It doesn't have to be perfect. But I believe, if I look at this, my first point should be at 5, 2.3. There's about 5 and about 2.3. You got it? So let's take well, the next minute and do a scatter plot from the data I have here. Okay, so then the next dot will be at 8 and 2.8, which I'm going to estimate to be about there, okay? So we're going to do another point at 12 and about 5. Okay. I'm going to do another dot at 18 and about 7.5. 1, 2, 3, 4, 5, 6, 7.5. I'll estimate to be about there. And then I'll do another dot at 23, which is about there, and 7.9. It's about there. And then I'll have 27. I'll estimate 27 and 9. And finally 30 and 11.8. So 11.8, I'm just going to estimate 11.8 is right about there. Okay, so we've got a scatter plot. One of the reasons I like this lesson is you can see here where you sped up, you slow down. Which is okay, it was a fun activity. And real data, whether you're sampling coronavirus or whatever you may do, right? Real data works the same way. Real data works the same way. Sometimes you might get a high population in one region and a low population in others. So real data is never true. It's always a little bit messy, and your real data was a little bit messy because that doesn't look exactly like a straight line, does it? Okay? It's close. It's close to a straight line, but it's not exactly a straight line. So what we want to do is we're going to do this. We're going to find the line of best fit. So I'm going to write this down. I'm going to try and find the line of best fit. Okay, so if you need a ruler, get up, grab a ruler. Everybody needs a ruler. If you need a ruler, get up in the back, grab a ruler, because the line of best fit here, we can share mine. Can we share mine? That'll work too. Okay? So my line of best fit, I'll let you grab a ruler.
Hey, Jose, will you throw me one?
He needs it.
Here, one for Max too.
I already got a big one.
Okay. Now, everybody good? Watch. Okay. Give me 5. Give me 5. I'm waiting. So, the line of best fit. This is kind of like up to you, but if I take a look at my ruler, I'm not going to hit all the points. I'm not. So I'm going to try and fit my line in the best I can where it goes through kind of like in the middle of all the points, right? So I'm going to guess that my line of best fit might be right about there. Okay, that's my line of best fit, okay? And what I'd like to do is find this equation. And we know how to find this equation. We know how. We've been doing this all week. We're going to have decimals. It's okay. I can do decimals. So what I need to do is look at my graph. And I'm going to pick any 2 points. Now, you get more accuracy the further the points are. And you want to find that 2 points are probably close to my line. I really think I'm going to pick this one and this one. Does that make sense for my line? I'm going to pick these two. They seem to be the closest to my line, and I don't want them to be too close together. So I'm going to pick probably this point and this point. So I'm going to pick any 2 points because I need 2 points to make a line. So those 2 points correspond to my chart, to the second one and the last one. Okay? Those are the 2 points I just picked. So what I'd like to do is get the equation of this line, right? So to find the equation of a line, I'm going to need my y minus y1 equals m times x minus x1, just like we've been doing, but from the 2 points I picked. Before I use this equation, though, I need to find the slope. I need to find m. And to find my slope, I'm going to go y2, 11.8, minus y1, 2.8, divided by x2, which is my 30, minus x1, which is my 8. Okay, I'm going to snag a calculator to do this. So I just want my y2 minus y1 over x2 minus x1. So I'm going to grab a calculator, and just because I've got decimals to work with, so grab a calculator real quick. Let me do the math. So I'm going to go, yeah, that's 9. 11 I got good numbers. 8 subtract 2.8 gives me a 9 over, what'd you guys say, 22? So we got 9 over. So that's my slope. So I'm going to put that into my equation. We're going to write y minus 2.8 equals 922 over x minus 8. Okay? So what did I do? I took my slope, which was 9 over 22, put that in for m. I took my x1, my y1, x1, y1. My x1, y1 for my equation. Now, 922 is kind of a bad fraction, so what I'm going to do is just use a decimal and use my calculator. So I'm going to change this to a decimal and just use my calculator. Okay, so what is 9 over 22? My calculator is going to tell me real quick. 9 divided by 22. Yeah, about 0.41. So I'm going to go y minus 2.8 equals about 0.41 times x minus 8. And I'm going to solve. I'll go and distribute this times this, this times this. So I'll have a y minus 2.8 equals 0.41x, and then 0.41 times 8. It's about a 3.28, so minus a 3.28. I'm going to add my 2.8, add 2.8. And I'm going to finally get an answer of y equals my 0.41x. Let's see, negative 3.1828 to 3.28 plus 2.8. About a negative 0.48, or go negative 0.5.
Oh.
Okay, now, this is the equation, but this is the equation of number of people and time. So I'm just going to reassign variables because x and y don't really mean anything. But we're going to reassign variables as time is equal to 0.41 n minus 0.5. Okay? So let me back up and recap what we did. Okay, I want you to see this. Okay? Here's what we did. We took our data by doing the wave. I did a scatter plot of all my data points. I just made a scatter plot. I looked for the line that fits the best. So I tried to find the best line, use my ruler, drew it in. I need 2 points for a line, so I chose these two. They're closest to my line, yet they're far apart. And I did my equation. I need a slope first. I changed that to a decimal. I used the equation of a line with point slope, and I got an answer. Now, my equation deals with time and number of people. Now let's think about this, okay? This number here, 0.41, tells me how fast you went. You were doing it about 0.4 seconds per person. So you were going pretty fast, weren't you, right? So, because you guys whipped around, okay? This number here doesn't really make any sense, but that's the number we have. Why does this number not make any sense?
Because you can't have 0.5 people.
You can't have 0.5 time. If 0 people go, how much time? Zero, right?
Unlimited.
Okay, but that's how it happened when I drew my line in. It's probably going to cross right about there. Does that make sense? Okay, so we're going to keep it. Okay, now, let's keep going with this. Okay, so now the next thing is I can use this. So I'm going to turn my page. I have a t equals 0.41 n minus 0.5. Okay, now we can predict now. So we could do like 1,000 people, but we have to go around,
Let's do it.
around, and around, and around. Or we could use our equation, right? So if I wanted the time, so question, if I wanted the time, what is the time for 1,000 people? I'm just going to use my equation and plug 1,000 in. So I'll take my 1,000 and I use my equation. So I'm going to rewrite this as t equals 0.41 times 1,000 minus 0.5. So let my calculator go 0.41 times 1,000 minus 0.5. And what do I get? About 409.5 seconds, right? 409.5 seconds. Does that make sense? So we have an equation that we can use. Because doing 1,000 people would take us probably, well, it would take us more than this period. We'd probably be into fourth period, right? And that'd be no good. Now, we could also do this question. So here's my next question. How long would it take? We could do 1,000,000. We do for let's do a little smaller than 1,000,000. Let's say let's go 36,000 because that might be how many people are in a stadium, right?
36,000.
Okay.
That's more than the population of the match.
So isn't that crazy to think we get more people in like the Husty Stadium than all the people in Wenatchee? It's insane to think of that, isn't it? So that's my how long is my time, right? So I just plug in 36,000, right? Okay, so I can do the same thing. I can go, okay, t equals 0.41 times 36,000 minus 0.05. Same thing, right? So I'm going to just use my calculator. I'm going to go 0.41 times 36,000 minus my 0.5. I get an answer of about, it's a lot of seconds. I got 14,759.5 seconds. Okay, now, if I had to change that to days, what would I do? Days. First, let's divide by 60. That's how many minutes, okay? Let's divide that by 60 and we'll get how many hours. So it's about 4 hours, right? Take us about 4 hours for that to happen. About 4 hours?
1 hour.
Yeah.
Is this if it's just in a straight line?
Huh?
Is this just a straight line? Or?
Yeah, it is. So now, last question. Okay? Last question. So, the wave lasted for, let's say 24 hours.
Dang, a whole day?
How many people would we need? Okay, so, all right, first of all, 24 hours. How many minutes is 24 hours?
6,500.
How'd you get that?
I just guessed.
Well, how many minutes are an hour? How many minutes are an hour? So let's go 24 times 60, and we'll get minutes. So 24 times 60 gives me 1,440 minutes. Okay? And then, how many seconds are in?
Times 60.
Okay, so then we times that by 60 seconds.
57.
So we've got 86,400 seconds. Now, if I set that equal to my formula, I could predict how many people I'd need. That's the time in terms of seconds, right? Could I solve for n? What would you do to solve for n? Not yet.
Oh,
Add 0.5, which is not going to make much. Add 0.58, add 0.5. Now what am I going to do, Giselle? Divide. All right, let's see what I got. Divided by 0.41. I would need, I'd need 210,733 people.
Pebbles.
That's like 2 states.
Or we just keep going around and around and around and around for 24 hours, right?
Let's do it.
round and
Right.
around.
Okay. So, yeah.
To get a number like
No,
close to that,
please.
you could just multiply 4 by 6.
Yep. We did that. Yes.
And it'd be like 10 times easier.
Yeah.
Oh, well, where's the homework?
Yes, you're correct. All right. Now.
Homework?
Yes. We pause it.
Grab people.